Welcome to solverfy.
In this problem, we're asked to determine the area moment of the shaded area shown with respect to the x and y axes. So I've drawn the area kind of in two pieces, and so what we're going to do is the area in the book is kind of basically this rectangle with the semicircle added on and a semicircle added off, cut out. And so we're going to find the area moment of this shape and then of this shape about x and y, and subtract this from this. And that will give us the area moment of the shape that's in the book, where this region here is removed. So that takes basically, and given all the dimensions we need in terms of A, the radius, or the radius of these semicircles. And so for this section here, we just have 1/3 2a for about x, 2a times a cubed, and about y we have 1/3 a times 2a cubed, and then for 2, right, we have about the centroid. Okay, the centroid is, say, of this section here is up around here, and we have that that is the we haven't from the book that we have the radius or the area moment about an axis here, but we want an axis through the center of mass. So we got the area moment about this axis is this. The area of this thing is pi over 2a squared, and then the distance from this point here at the center of this semicircle, or at the center of this circle that's from the semicircle, to this is 4a over 3 pi. And so we multiply it by that squared, and we subtract it because this is the area moment about this point, and we want about the center, the centroid. And so we multiply all that out, and we get pi over 8 minus 8 over 9 pi a to the 4th. So that one's pretty ugly. This one, again, we can figure out about its centroid, which is here, and we're given that in the book because this axis passes through the centroid, and that is just pi over 8 a to the 4th. So we want to find the area moment about this point. So we take the area moment of this cross section about its centroid and add to it the area, pi over 2a squared, and add to it the distance from here, from this x-axis to the centroidal x-axis, and that is a times 4a over 3 pi, and then square it. And so we do all this out, and we get 3.30 a to the 4th. And now we want about the y-axis, so we have about the centroidal y-axis, and then we times the area times the distance from this y-axis to the centroidal y-axis is just a, so we get 5 pi over 8 times a to the 4th. And now we need to do a bunch of other calculations, and this one isn't too bad because this is just a rectangle we're going to do, and then we're going to subtract off that. So that rectangle has an area moment about this x-axis. Again, it's just at a corner here, so that's 1/3 2a times a cubed, and then about the y-axis is just 1/3 a times 2a cubed. So that one was pretty easy. And now we need to get this red area here, although I've used blue here, but in this red area, again, so we know the area moment about this point here for the x and y axis from the book. And we can also figure out that, what about the centroid using this formula here. Okay, so about the centroid we get this value and this value, again, because it's the same with respect to its centroid, it's the same as this one with respect to its centroid. So we have this, and so now we need the distances from here to the centroid. And this distance is a, and this distance back up from here is 4a over 3 pi, so we get 1 minus 4 over 3 pi squared times a squared, and so then the area, and then that all comes out to be 0.6308 to the fourth. And from the centroid of y-axis to this y-axis, we have a distance a, so that one's easy. So we get 5 pi all over 8a to the fourth. And so we can see that, in fact, that one about the y-axis, this one and this one are going to cancel out, because basically we've removed stuff with respect to the y-axis in the same kind of, we've added and we've removed, and they're all just shifted along the y-axis. Now the x-axis is going to be different, because this one's added farther away and this one is added or subtracted closer. So we have all these values now, and we can just simply add these three up and then subtract off that cutout, and what we get is oddly a very even numbers. The area moment about x is 4.0 a to the fourth, and about y is 16/3 a to the fourth. And I would assume that because those are so clean of numbers, that there may have been a simpler way of calculating this, but I didn't see it. So we got our answers here.